I'm Colin Dixon. I'm the chair of the Technical Steering Committee, and I also work for Brocade. Phil, if you just want to take a second to introduce yourself so people can latch on to voices, that would be great.
Sure. I'm Phil Robb. I'm the Technical Director of Operations for OpenDaylight, which in general means that I just help the community move along and keep putting out great code. So look forward to walking through Beryllium with you today.
Yeah, and both Phil and I have lots of responsibility and no authority over this stuff. So in general, if something looks good here, it's probably somebody else's work, and if it looks bad, it's it's probably our fault. So keep that in mind.
Well put.
So why don't I get to start off? So the most recent release of OpenDaylight is Beryllium. We're going along the periodic table, so the next one will be boron, and then nitrogen after that. So if you don't know your periodic table, you can learn it slowly by following OpenDaylight releases. And so we're just going to talk a little bit about not just what's new in Beryllium, but also sort of how OpenDaylight has moved in the last about 6 months, or about 6-month cadence for releases of OpenDaylight. So, and if you have any questions, we'll be trying to answer them either in line or at the end, and please do put them out there. So I just want to start off by setting the stage with sort of where OpenDaylight fits in the broader open source SDN ecosystem. And so this is a list of the total contributors in terms of people and the total code commits according to openhub.net as of February 2016, which was when Beryllium was released. Beryllium was formally released on February 22nd. So this is, it's the most up-to-date data that we have. And you can see that if you look at the number of people working on open source SDN and the amount of code in the terms of commits being pushed, that OpenDaylight amounts to something like half of the whole open source SDN ecosystem, and this has been pretty consistent over time for the last while. Obviously, you'll recognize some other major projects, including OpenVSwitch, we work with very closely, as well as Contrail and ONS. And so there are a lot of people working on open source SDN. There's a lot of code being written, and about half of it is being written for OpenDaylight. So it's a really exciting time to be involved in open source SDN. And if you want to get involved, OpenDaylight's a really good place to come get involved and get started. So that's just the broader open source SDN ecosystem. But specifically, we want to talk a little bit about how OpenDaylight and how it's being used, because I think a lot of the biggest changes that have happened between Lithium and Beryllium have been less about the technical advances that we've made, although there's quite a bit of that, and I will talk to it, and more about the shift from OpenDaylight being a tool for proofs of concept and research deployments into something that is actively running in production and being used to solve real problems for real customers and for real users. And so the way it's being used and how it's being used has driven a huge amount of what we developed in Beryllium, and also has a huge amount of what's changed about OpenDaylight in the last 6 months. And so we do a survey that corresponds with each release. And it's sort of an OpenStack does a similar thing, where we basically ask, who is using it for what and why. And so on the right, you can see sort of some overall results of the survey, and I'll just highlight a few of them. One of them is basically lots of people think that OpenDaylight is for just one thing, like just for the data center, or just for enterprises, or just for research and education. And in practice, we're seeing really broad adoption for use cases. Here we called out new service creation, which is usually something that is deployed by service providers, NFV and cloud, which is usually if it's in the data center, traffic engineering, which could fit in any of those places, and sort of network monitoring analytics, which again sort of could fit in any of those places. But we see really broad use of OpenDaylight for a huge variety of different tasks. And I'll get into how we're starting to categorize those tasks based on user feedback a little bit later on. And at the bottom, you can see how our users are distributed. And you can see they're distributed pretty evenly between North America, Europe, and Asia. And in particular, I'm really excited to see the progress which is happening in Asia. Specifically, Japan and China are both showing a huge amount of interest in OpenDaylight. And we've seen Tencent, which is one of the largest web-scale companies in the world, in China, not just joining OpenDaylight, but actually running it in production in their data centers and acting as an advocate for trying to get other people to get involved in open source SDN and OpenDaylight in China. And so we're spread pretty globally, at least where there are significant technical populations, and we're spread across all sorts of different use cases.
Yeah, and I'll just add that that it's really helpful to us to actually see that building a platform that can manage a large variety of different use cases with an architecture that allows for different southbound plugins. And a plethora of different services that leverage those to actually watch the different use cases that we're starting to see go into production across these different models, right? And across, be it traffic engineering, be it NFV and cloud. So the leverage of the components is what we were hoping for, and that's exactly what we're seeing come to fruition here.
So yeah, and thank you, Phil. That's absolutely the case. And so this next slide just is more results, and it makes the same point I made before, which is that we really aren't a single focus open source project. We really do not only try to support use cases widely across the board, but actually the people adopting it for those uses are pretty evenly split between people developing products out of OpenDaylight, people using it for research and education, people using it to provide as service providers, and people using it for enterprises. And so this just speaks exactly to what it is that we've been saying, which is that we designed a platform to be usable for as broad a set of environment in SDN as possible, and we appear to be delivering on that based on what we're seeing our users tell us. And the key business drivers that people go to adopt it really are what you would expect, which is that people want to adopt open source solutions because that allows them to innovate and compete. And on the right, you can see by writing their own network applications, and also to tie into the ecosystem in the middle. And I believe that really it's the ecosystem and the community around OpenDaylight that are probably our biggest advantages. And that was really highlighted before when I showed, we really do make up about half of the open source SDN ecosystem. And so being able to tap into that power is really truly liberating and compelling. And if you haven't tried it yet, I encourage you to do so. So that was really about OpenDaylight, the open source SDN ecosystem, OpenDaylight, and how our users are using it. And you really came here to talk about about the Beryllium release. So it would be I'd be remiss if I didn't get there. So this is the high-level architecture diagram for OpenDaylight Beryllium. It is, and if you don't understand every single point on here, that's fine. You can go read more about them on the download page. But the key points I wanted to call out is that we essentially have an architecture which is drivers for different kinds of southbound protocols and devices at the bottom. Then we have an abstraction layer, which provides essentially the runtime and ability to interact between network services and applications and everything that runs on top. We have network services, which are designed to provide enhanced abilities, services you can rely on or to build better applications. Then we have applications, which would run on top of all of this, and they access things either via Java APIs as well as through REST APIs, and or we have new bindings in Beryllium for things like AMQP. And so so the key point here is there's a lot of things here. You don't have to use them all, but they're all there if you wanted to use them. The ones in beige with black text are the ones that are new in Beryllium. And just because something isn't new doesn't mean that they're just because things aren't new doesn't mean that it didn't change a lot. So for instance, the clustering support for applications improved dramatically in Beryllium, and many applications took advantage of that. Most of the applications that took advantage of that were already there. So even though the OVSDB Neutron service did a massive amount of work to become highly available, that isn't reflected because they were there in previous releases. So next I'm going to talk about sort of the major focuses of what I think we enhanced in the Beryllium cycle. And after that, I'm going to talk about sort of how we're grouping use cases based on user feedback. And then I'll talk a little bit more in depth about how you might download and play with OpenDaylight and what you might want to know. So the first major thing that we pushed on for Beryllium was around performance and stability. And this again ties back to what I was saying, that the biggest thing that happened maybe wasn't technical, but was a shift in how our users were consuming OpenDaylight, that we saw more production deployments and more more interest in actually making this something that solve real problems in reality. And so this has resulted in exactly what you expect, which is that people really need it to be highly available, stable, and performant. And we've done a huge amount of stuff in this space, both in terms of the core of OpenDaylight in the form of enhanced clustering, which I mentioned earlier, but also improving the performance of applications that run on top, including enhanced scalability of many of our plugins. For instance, our support for OpenFlow and NetConf is noticeably enhanced. Enhancements that allow us to scale out in performance and clustering. So our NetConf implementation will actually just linearly scale out with the number of nodes that you add to a cluster. We also have accelerated some of our network service chaining features. So now we have the ability to essentially deploy virtual network functions or middle boxes on particular hosts in OpenStack in order to be able to make sure that you're getting the best performance out of those virtual network functions you're deploying as possible. And that's DPDK, accelerated virtual switches. We also have one of the strongest and most exciting integration and testing communities I've ever seen anywhere, never mind in an open source project. Traditionally, open source projects are not so good at that. We not only do we do a huge amount of testing, but we spend over $1 million as a project on it between a Linux Foundation staff member who helps to keep the infrastructure, Linux Foundation staff members to help keep the infrastructure up and running, and also just in fees for the cloud services that we consume in order to do that testing. And the result of all of this is that we have a huge and very robust set of tests that help us make sure that not only are we improving, but that we aren't accidentally introducing regressions, and that new code can be ingested quickly and confidently that it's going to do the thing that it says it does, and it's not going to break other people. And so this has all really been about how do we provide confidence to our users as they go to actually put this into reality. So the next major, so there's a question in the chat about do we have any numbers in terms of the performance improvements. At the time of the Lithium release, the scalability of our OpenFlow plugin was on the order of was working in our Rackspace VM at the order of about 250 to 300 switches before it stopped working. And now it works much higher than that if you're running on bare metal with a well-tuned server. We've heard reports at that time it was about 1,500 with some work that was done by Steve Noble experimenting with that. And these days, we actually have a test that tests up to 500 switches in the Rackspace VMs that we test with, and that one passes 100% of the time. So we've at least gotten something like a 2x improvement in the scalability of our OpenFlow support. And it's probably a little bit more than that because the test doesn't test beyond 500. And so my expectation is it's pretty much across the board performance improvement in the realm of like 2 to 3x in terms of scalability and performance. And there's lots more numbers at the OpenDaylight wiki where we've been publishing. We've been trying to aggregate all of our performance and testing into one place. So I would expect that we will have a more user-friendly set of performance and scalability numbers available in the near future.
Yeah, we've also got several outside groups that are working on performance numbers that I think will be coming to light relatively soon. As well as we hear word that there will be an actual high performance team that will be starting up as a proper project inside of OpenDaylight as well in the not too distant future.
So the next thing I want to talk about that we focused on really heavily in Beryllium is OpenStack integration for providing network virtualization via the Neutron API. And since the very first release of OpenDaylight, we had support for OpenStack Neutron. And it continues to be a really important use case for us, although by far from being the only one. And in Beryllium, I think we've closed the gap between OpenDaylight and pretty much the remainder of the Neutron providers that are out there. So we provide support for not only just the normal ML2 plugins, so standard network subnets, NICs, and virtual NICs and the like, but also support for fully highly available Neutron, as well as adding support for hardware VTEPs, security groups, load balance as a service, VPN as a service, and the like. And so at this point, I think OpenDaylight is as capable a Neutron provider as any other out there. And beyond that, it's increasingly becoming sort of the go-to point for interactions between OpenStack, Neutron, and service chaining. In particular, the service function chaining project, or SFC, inside of OpenDaylight interacts with the Tacker project in OpenStack in order to be able to start doing network function virtualization. And so we haven't seen as much deployment of network function virtualization with OpenDaylight as we've seen with other things, but it seems to be becoming the platform of choice for proofs of concept. And I suspect the deployment gap is temporary and an artifact of how relatively recent network virtualization is rather than anything else. So the higher bit is, I think we actually are now as good a Neutron provider as anything else out there. The third thing I really wanted to highlight is enhanced tooling. So we have a whole bunch of additional pieces that exist around and outside the controller itself, designed to make it easier for people to both build applications as well as integrate OpenDaylight into their real-world deployments and into the broader IT ecosystem. And so this, again, it's really about the fact that people are actually using it for real things. And so you have to deal with the reality that that you are not the only thing, that you have to interact with other systems, and you have to also provide tools that make it easy for people to consume and use it. And so just to highlight a few, we have the Next UI toolkit is a developer toolkit that allows for building really rich sort of layered network visualizations, which are pretty common to want to render in sort of when doing things like SDN, but are often difficult to make look good or even make them work at all. And so that's, I think is going to enable a really cool new set of applications for OpenDaylight that provide rich feedback to users. The NetID project is new and delivers an ability to run applications written for different SDN controllers on top of OpenDaylight, assuming that they're written using OpenFlow. And so this enables Floodlight, Paretic, and Ryu applications to run on top of OpenDaylight natively. And so if you have an application that's been written for one of those controllers, it means that you could migrate to OpenDaylight and get the advantages of OpenDaylight without having to worry about leaving your applications behind. And lastly, and there's a question in the chat about this, which is for support for analytics. The TSDR, or Time Series Data Repository project, and the Sentinel project are about extracting data from OpenDaylight and sending it to external data stores specifically for doing analytics and essentially and big data analytics and dealing with streaming data. And so they allow, I think right now, for export to things like HBase and Cassandra, and it's a plugin based architecture. So if you have a different kind of data store that you'd like to export data to, that will be relatively easy for you to add if you wanted to. And so these tools are really about making people's lives easier, both to build applications as well as to deploy and manage OpenDaylight. And it's worth pointing out that there's another tool that is not on here because it wasn't officially part of the Beryllium release, but is still part of OpenDaylight, is the Yang IDE project. And the Yang IDE project was actually brought in by AT&T, who is using OpenDaylight in production, to aid in the creation of Yang models, which form essentially the centerpiece of OpenDaylight. So it allows for the creation of Yang models using a nice graphical user interface, and it provides suggestions. And so the fact that we have users who are actually running it in production contributing their tooling back, it is probably my single favorite thing that is currently happening in OpenDaylight. That's that loop that once you close it, starts to make everything better again and again and again. And so this is just a quick diagram of how NetID actually works. I just like this example because it's kind of a cool project. It came from a bunch of different companies, including Telefonica and a couple others. It's just a pretty cool idea they had, which is that you could use OpenFlow as the interoperability layer between different SDN controllers. And the result is that you could allow portability between OpenFlow applications. If you get a chance, I really suggest go checking it out. It's a pretty cool stuff. And the fact that it allows people to bring their applications with them to OpenDaylight makes me incredibly happy. As I go into talking about sort of broader parts of OpenDaylight Beryllium, I'm going to talk about them in the context of 5 use cases. And this is just because we don't really have time for me to go through each individual project in OpenDaylight in detail. We have, I think, 50 projects in Beryllium. And so I covered some of the highlights of what's changed, but I also want to cover some highlights of sort of what it's being used for in reality and how it's providing those features. As part of our user survey, we really found that there are 5 main use cases that people are using OpenDaylight for. The first one is automated service delivery, and this is the ability to provide new services quickly, usually to your customers. And the canonical example of this would be something like AT&T using OpenDaylight to deliver bandwidth on demand services, which they currently do. So it's a way for them to offer a new service, which is bandwidth on demand, and offer a self-service portal where users can go click and actually order additional bandwidth as they need it. And so it's not, that's one example, but people are using this, especially in the service provider space, to be able to provide new services, totally new services quickly, as well as to provide instances of those services quickly to users from user service portals. We see a lot of people using it for this purpose, service providers being the most common. The second one is network resource optimization. And this is essentially if a user typically builds this in-house for themselves, but if they have a networking problem which is causing them problems or costing them more than they would like, and they want the ability to go in there and more carefully optimize or more efficiently use their network resources, they can use OpenDaylight as a platform to do this. And so Tencent, who I mentioned earlier, is doing exactly this with OpenDaylight to help manage the traffic between their data centers, so their inter-data center traffic. And this typically involves a pretty deep level of engagement with OpenDaylight, and as well as understanding of your own problem domain and writing applications essentially that target your particular needs. There are also people that are trying to do this in a general way. Brocade has a product called the Brocade Flow Optimizer, which does similar things, although without the domain expertise of the particular network. It tends to do them in ways that are, the ways you might expect, which is to say rate limit big flows, or remark certain kinds of traffic, like say BitTorrent as lower, as opposed to solving the very specific problem of 10 cents WAN utilization. The third use case that we see people adopting is visibility and control. And this is really sort of the starter use case for people. People that want to get involved in SDN but aren't interested in re-architecting their network or changing everything. And so OpenDaylight is essentially a very advanced NMS, a network management system, in that it speaks a huge number of southbound protocols and is able to gather a huge amount of information about your network, and also able to let you actually go out and make changes to that network based on that data. And so there are many people using OpenDaylight because simply it's the best way to, in a single software package, understand what's going on in their network and change what's happening in their network in a way that is extensible and also programmable. And so these are all sort of various forms of, they're brown because they're brownfield deployments. They're taking an existing network and trying to add additional capabilities or additional functionality on top of what's already there. The last two are greenfield deployments. The first one of which is cloud and NFV. And one of the interesting things that we found as we were hearing from our users was that cloud and NFV are actually pretty much the same use case. And to be a little bit more precise, that NFV is a strict superset of cloud. That everything that people try and use OpenDaylight as a cloud networking provider need, people doing network function virtualization also need. So in order to do network function virtualization, you need the ability to spin up virtual machines in order to house your virtual network functions. So you can have a bunch of VMs act as a firewall instead of having a hardware firewall, which is the same as cloud. You also need the ability, in order to have highly dynamic network connectivity, you need to have the ability to have tenants. You need the ability to have essentially remote access to the infrastructure, so VPN as a service. So you really need all of the same things there. But in addition, you have the requirements of establishing service chains, so being able to route traffic through chains of these virtual network functions. So first it should go to the set of firewall, the set of VMs running the firewall, then it should go to the set of VMs providing the load balancer, then it should go to something else, and then it should be delivered to the server that needs it. And so that service chaining is sort of just an additional requirement beyond what cloud does. So we really find that's the same use case, just the NFV one is even harder. I think OpenDaylight is present in a pretty large number of where people are trying to deploy NFV. Again, mostly at the proof of concept level at this point, but I'm expecting that to shift a lot during the next 6 months. And the last use case that we see is, and we see quite a bit of, is research, education, and government. And this is sort of greenfield deployments of specialized networks. So this is something like Internet 2, which is the network, there's a large university network connecting different universities. The city of Bristol using OpenDaylight to control their municipal network that includes connecting sort of Internet of Things style things. And other similar cases where there's a new network being built for specific use cases. And usually this is happening in the research, education, and government space. But it's less about who's doing it and more about, having a new network designed for specific use cases. And so the next slides talk about these with examples. So when it comes to automated service delivery, We talked about AT&T On Demand. The Sero Solutions is, I'm pretty sure, is the satellite. Is that right, Phil?
Sorry, yes, it is.
Okay, and so this is the satellite system allowing for basically, a lot of their customers are essentially mining operations and things like that who need satellite connectivity. And so they are using OpenDaylight to actually orchestrate satellite links to provide connectivity to remote locations. Telstra has been using it in order to deliver new services in the form of data center interconnects for their customers. The Large Hadron Collider is using it to distribute data more effectively to universities. These are examples of, you need a new service and there isn't a good way to deploy it except via SDN. And OpenDaylight is an exceptionally good way to deploy new services using SDN. When it comes to network resource optimization, I think we talked about what Tencent is doing. There are many other people doing this. But using this to do anything from multi-layer WAN optimization, so joint optical and electrical pathing, to doing remarking, to reconfiguring existing paths in specific cases, to providing carrier LAN services. Visibility and control, I mentioned, is sort of really trying to do single way to look at what's going on in your network. I mentioned the Brocade Flow Optimizer in the context of network optimization, but I mean, you could definitely see it this way as a way to get a better view of what's going on in your network and how to react to it. We also have some users in the form of Telefonica are working on things in the space, as well as some service providers, I guess, really consultancy providers providing similar tools. So this is sort of OpenDaylight being used as an NMS. So, and then Cloud and NFV, I think I talked really heavily about this. It's being used in particular by China Mobile and Orange and the Massachusetts Open Cloud, but it does all of the normal things that you would expect Cloud and NFV to do, including network virtualization and the like. And lastly, research education. I told you about Cornell. We talked about the city of Bristol. SurfNet and Jayant are large research network providers in the EU. And so those are really, and I just want to stress, those 5 use cases are not, this is not top-down driven. This is not something where it is that we said, these are the 5 use cases OpenDaylight will support. And do it from there. This is really, we built a platform and we saw what came into the platform. And these are the clusters of what people are using that we've seen emerge from that platform. And so this is really about how users are choosing to adopt SDN and choosing to deploy the platform, not about what it is that we think that users should be doing. Phil, do you want to add anything to that?
Sorry, no. I have to admit I'm busily answering questions that are coming in.
I appreciate that immensely. No, there is no way to do feature :install for the next command. It is distributed as a developer toolkit. So next is not a user interface in and of itself. It is a developer toolkit which you can use. There is a download available for that developer toolkit, which either is on the website now or will be on the website very, very, very shortly.
Yeah, I actually pasted it into the chat, so it's just above. Another person asked about next as well, and so the URL is actually in the chat for everybody.
Perfect. I'm only looking at things labeled as questions, not things labeled as answers, so that's why. So okay, so cool. So now that you have some ideas sort of what's new in OpenDaylight Beryllium, what people are using it for, I wanted to give a little bit of context about how you could go out and get involved. And so there'll be a link to a downloads page in a couple of links, but if you search for download OpenDaylight, my guess is it comes up first. And maybe not, we should probably fix that. But I'm sure Phil will put in the link to the download page. And you download it, you can go play with it there. There's a getting started guide, which has been wildly improved for the Beryllium release, which I think provides a lot of, not only an introduction to how to actually like run it and get it started, but also an introduction to the concepts and sort of what you need to understand to be able to run it and maybe even think about developing it. So there's 4 main components that I think a user should still care about OpenDaylight, even though they're internal in their details. If you want to download OpenDaylight and use it, understanding that these exist is useful. So we use Apache Carafe as our runtime. It is a container that basically is for running Java services, and in particular OSGI Java services. But really what it is it's a container that lets you install new applications and see what you have installed, as well as generally understand the health and what's going on inside of OpenDaylight, and really easily enable and disable different functionality as you see fit in your particular use case. And so Apache Carafe is sort of how we distribute things. Think about it as sort of what OpenDaylight's equivalent of Docker, something like that. It's not actually an operating system, it's just a container, but it's a way to spin up OpenDaylight quickly and easily. Deluxe is our web-based user interface that allows you to basically get a web interface to OpenDaylight, see what's installed, see your network, see what hosts are attached to your network, and the like. It's also highly extensible. And so that's where Next comes in, which is if you want to write a Deluxe extension Deluxe, you can also pull in the NEXT visualizations in order to build really rich topological visualizations of whatever it is that you're trying to help users accomplish, and actually publish that as a Deluxe application. And lastly, but probably most importantly, is the MDSAL, which stands for the Model-Driven Service Abstraction Layer. This is essentially the core piece of architecture of OpenDaylight, which allows for applications to coexist in a microservices architecture and consume various plugins and network services, as well as provide functionality to users. And so all of the interfaces to the services are defined using Yang. So if you show up and want to provide a host discovery service, you would model that service in Yang, say, what data is it providing, what RPCs does it provide, does it have any notifications, that kind of thing. And then you would actually publish that service to the MDSAL using that Yang description and implement the service itself, usually in Java, but you can write it in any language you want as long as it can eventually attach into Java via some other mechanism. So these are the core concepts. If you want to go down and play with OpenDaylight, I think it's useful to understand. Again, the Getting Started guide provides a deeper look into these as well as other things. We are in the process of providing essentially web-accessible Javadoc for all of the different APIs that are available in OpenDaylight. The core APIs for all of OpenDaylight are already up. So the ODL parent Yang tools and MDSAL are 3 projects inside of OpenDaylight that essentially together provide the absolute core parts of what it takes to build an OpenDaylight application. And so they also include all of the core APIs that the rest of OpenDaylight is built with. And we'll get more of the higher level APIs, including ones to access the ability to track hosts and things like that, up over the next couple of weeks and months. They are all available if you build the projects, just getting them up and online and posted. We want to do it in an automated way, so that way it was continuously deployed. So those are the most recent Beryllium documentation for each of those. So if we make a change, you will be notified about it immediately. And so we're continuing to improve upon that. There was a question in the chat, which I'll just take a chance to go after, which is, are there any ODL applications that we downloaded and used in ODL training courses? So there are, and it mentions Mininet. So the example I always have people use is the L2 switch project and Mininet in OpenDaylight, where you can actually do demos where you can get playing with bringing up L2 switch, which will give you connectivity between all of the nodes in Mininet, and you can modify it to do other things like, say, create 2 different availability zones, or sort of 2 different basically tenants in the L2 switch. That way, one person can't see the other person's traffic, or their hosts data won't be forwarded between them. So that's typically what I do, when I'm doing a training course. There's also been a series of SDN bootcamp events in a variety of locations on top of OpenDaylight. So if you search for OpenDaylight bootcamp, you'll probably find it. If not, I'm sure Phil will be happy to provide some information there. And there are a variety of companies that provide training. I know Inicybe is a member company, which tends to provide a lot of training around OpenDaylight and how to build applications. I think Brocade also offers training, but it tends to be on a with already engaged customers. But there are people looking to provide training and can help you out. Now, Phil,
yeah,
there is a wiki.
Yeah, no, there is a wiki page as well called Core Tutorials, which is in need of further work, and we will be working on it. But there is some good information in there as well. And like I said, keep your eye on that page in particular, because we'll be shuttling more community activities there.
And I'll just I'll close off with I mentioned this earlier. You can download OpenDaylight, look at the Getting Started guide, or also find people that are providing products based on OpenDaylight, as well as offering services based on OpenDaylight. So generally speaking, get involved in or start developing with OpenDaylight. And you can do all of that if you go to opendaylight.org/start. If you go to opendaylight.org, and that will take you to where you can download OpenDaylight or find anything you need. If you go to opendaylight.org/downloads, that will take you to the download page, which includes the Getting Started guide as well as actual links to download the code. And if you want to get started as a developer, we are on IRC, and we have mailing lists. And I will put those information into answers for people that are interested in being involved in the development. We usually have sort of 2 major meetings a week. We have a technical workstream meeting on Mondays, which handles sort of interesting technical problems across the project. And then we have the technical steering committee call, which tends to be more about major events going on in the project and sort of release planning and that kind of thing, which is on Thursdays. And you can find out all of our meetings if you go to wiki.opendaylight.org and then search for meetings. There's a meetings page which lists all of our meetings, and you can get involved. And so with that, I think that we're about 45 minutes into the talk, and that's pretty much exactly what I was aiming for. And I think we'll start taking questions. I know, Phil, you've been paying more attention. Is there a question you want to answer out loud quickly?
Let's see. No, we should probably just take them in order, I think.
Okay.
They haven't been answered yet.
OpenDaylight supports scaling feature in terms of VMs. So OpenDaylight scales can run in a cluster, and the cluster need not be VMs, or it could be physical machines. We test very aggressively with a 3-node cluster, where we use a strongly available data store, strongly consistent data store. So any one of those 3 nodes can fail, and the other 2 will continue to work. And that, because you have a majority left, it ensures that you don't have any cases where they might disagree about what decision was made. And it works on both VMs and in terms of and on physical machines. Probably easiest to deploy in terms of VMs, just because VMs are always easier, but there's no requirement to that. The cluster transactional sync performance. Clustering performance is a little bit lower than performance without clustering. I don't have specific numbers, but I suspect those numbers will be published very soon. I mean, we have the numbers, I just don't know them off the top of my head. Do we support scaling numbers? Scaling numbers for southbound netconf comparison with lithium beryllium. We do have them. I don't have them off the top of my head, unless Phil, do you?
No, I don't.
So I believe that I saw this morning the first attempt at pulling together all of our scaling and performance numbers into a single wiki page. If I can find that, I will put that out, and I can distribute that to people that attended this. There is a significant effort to try and, we do a lot of performance and scale testing. It tends to be done by individual projects and not aggregated up. And we're discovering that people really want to know the answers. So we will start aggregating them and probably publishing them in a user-facing way, in an easy-to-understand way soon, like in the next couple of weeks. The shim in NetID is Restcounts. That's a good question. Let me go look at that diagram quickly.
I had the same thing. It's most probably REST, but yeah, we'd have to go look.
It's possible that they implemented it as a Java interface, which then speaks AMQP. So if you look at this slide, but I honestly, I haven't been as close to that code as to say for sure. It's either going to be RESTconf as the interface or be a Java implementation that then works with AMQP. Okay.
Yeah, and I'm posting the performance wiki now.
Okay, and all of and most of our performance numbers are run as automated tests inside of our Jenkins continuous integration infrastructure. So if you want to know, you can go look at like, what did the last patch perform? So we're very public about our performance numbers, as we are with everything else. We don't. But there is nothing private in OpenDaylight.
No, but that said as well, we use these mostly for regression, right? We're watching to make sure nothing gets slower, by any kind of significant order as things get added, as opposed to a significant performance test bake-off effort with lots of tuning and hardware and so forth.
So that's a really good point. Our performance numbers, the ones at least that come from our continuous integration infrastructure, tend to take the form of tests that we run over and over again to make sure that no patch introduces a performance regression. And so it is not trying to get the best possible performance in the best possible way by getting the hardware right, tuning the JVM right, and and stripping all the applications out. If you want to do a much more aggressive let's get the best numbers we possibly can, performance numbers out, that's something we're working on, but it's not what you'll find there, mostly because that's not the most useful thing to our developers. Okay, how does the ODL platform discover NFVs? And I assume it's VNFs for virtual network functions. So that depends on how you're doing it. There is in some cases it can actually deploy them and so just know where they are. In other instances, it's just told where they are. It's sort of specific to the way it's being implemented in that network. So pretty much any way you want, but it's easy to add more if you want to do different things. Is network discovery and inventory working in Beryllium? It was not supported in Lithium. So I'm going to assume that this means the ability to go out and discover all the devices in your network. And I think it was working in Lithium and is working in Beryllium, but I'll give the caveat that it's sort of it's a plugin or southbound protocol specific task. So if the plugin that we have, say for SNMP, doesn't support going out and proactively discovering devices, you won't be able to proactively discover devices. So for example, I know for a fact that the OpenFlow plugin does automatically discover devices because they're configured to kind of the controller. I know that the netconf plugin does not because there is I don't think there's an industry standard for basically going out and discovering all the netconf devices in your network. And my guess is that most people wouldn't want us to actively go out and try and steal control of everything.
Yeah, and I would also say that SNMP does do discovery, but again, the MIB set that it's looking at is not fully populated either.
So yes, it does do it. It depends on what plugin, exactly how and when and under what circumstances. It depends on the plugin. And I'm happy to have a discussion about specific things if people are curious. Is there any feature install for Next? We've answered that. Are there any ODL apps that can be available for training? We talked about training. How feasible is it in terms of maturity to use a controller like POX through NetID and start writing a controller applications and using the existing Yang models? So with the caveat that I have not actually downloaded and used NetIDE, my understanding is that if you want to do a proof of concept or play with things, I would go out there and I think that, and if you're using OpenFlow 1.0, or is it 1.3 now? Do you remember NetIDE, Phil?
No, I don't remember.
Okay, so it's possible it's only OpenFlow 1.0, but don't take my word for it. Please go check. The NetIDE project, I think if you're using OpenFlow, it should do the translation in a reasonable way. And effectively that's because they realized that the only thing which will come out of the bottom end of POX is OpenFlow rules. And OpenDaylight supports a very nice interface for installing OpenFlow rules. And so as a consequence, all you need to do is sort of take the OpenFlow events and pass them back and forth. And it turns out that it's a simple matter of code in both the snarky way and sort of the somewhat painful way. But I would test it before running it in production, but that's true for everything. But I believe that it should work as long as you're talking about OpenFlow to OpenFlow. All right, so what OpenDaylight module would help depict links, connectivity, and the Deluxe topology visualization? Do I need Next for this? So the Deluxe has a default view of the topology based on, I think it's d3.js, but it has a JavaScript topology visualization that is it's not quite as advanced as what Next provides, but it provides it out of the box. You don't need Next just to get that. And that is populated by any module that exports topology information from what they have. And so that includes like OpenFlow, BGP, and a couple of other applications, a couple of plugins that actually populate the information about the topology of the network up. OVSDB also does. So these things all occur in the topology, and they're all published up into Deluxe. Is there a list of ODL integrators like their OpenStack integrators listed in the OpenStack site, ideally Beryllium release? There is a list of those. If you go to opendaylight.org/start, which is the big thing that is listed, there is find a solution or provider, and that has a list. Most of them are not at Beryllium yet because it's been out for 2 weeks, but they should be coming. So scaling federation and high availability capabilities. So we have we provide scalability and high availability through clustering. Our clustering is based on an implementation of Raft, the Raft distributed consensus protocol on top of the Akka cluster delivery system. And so and then we have built higher level services on top of that that allow for people to essentially easily implement the ability to have sort of one active node in the cluster and fail over if that node goes down, as well as to implement sort of active-active applications in the cluster. So you can be running on all of them and distribute load across them. And some applications have adopted one, some of them have adopted the other. So there are some applications which are merely highly available in the sense of the Akka and Raft implementations will detect when a node has failed and ensure that the other node is brought up with the same state. If there are other applications implemented in OpenDaylight which actually are fully sort of fully clustered active-active, in which case they will scale out correctly. Are there use cases oriented towards Internet exchange points or inter-NSP networks in general? Differentiated traffic class domains. There is a UniManager application which is looking at creating, I think, carrier Ethernet and differentiated services across IXPs. UniManager. could ODL be integrated in with Cloudify VNFM? Could, yes. Has it been? I don't think so. It could have been, but I don't know about it. But OpenDaylight is probably the most extensible and SDN controller out there. So if it looks anything like what I think it is, it certainly could be, and it sounds like a cool project. We'd love to have you come help do it. Is inter-SDN federation supported through the SDNI projects, and is that different than clustering? Yes, and yes, it is different. So the SDNI project is a project out of ITRI, which I think is a joint academic industry group in Taiwan, is where most of the developers have come from, and it provides essentially dissemination of topology information using BGP between controllers. And so that is one way to do federation between controllers. It is not the only way to do federation between controllers. And that is different from our clustering solutions, which are not really federations so much as they are a tightly coupled cluster of nodes accomplishing the same task. When will Restcounts be supported on the southbound? That's a good question. It was originally slated to come out in Beryllium, and I think that it's currently supposed to come in Boron. But if you really are curious and interested, the project that we provide Restconf southbound support is the NetConf project. There is a NetConf mailing list. I would encourage you to go let them know that you would like Restconf southbound. How is ODL integrated with Attacker VNFM? So right now, my understanding is that essentially there is a way for us to be able to discover the Attacker VNFs that are published in OpenStack and use them as part of service chains in the service chaining project.
Yeah, it's being led by the service function chaining group, and I believe there should be a demo of that actually working at ONS in the solution showcase.
I liked about what projects you have for encrypting traffic between switching the controller, especially controller traffic. I saw a previous project that was new in Lithium but wasn't able to find it and install it. Okay, so there is, so almost all of our southbound protocols support some form of encrypted transport. So OpenFlow supports TLS, and NetConf supports SSH, and I think OVSDB also supports some form of TLS. By default, because you have to configure them with certificates and things like that, most of them are not turned on by default. But it is something you can do. And controller-to-controller traffic is also is done. I believe it is possible to use TLS with Aka's messages. It is not enabled by default, again, because our experience is that users have very specific certificates and ways they want to configure encryption. And so that is part of how it is deployed and brought up on users or customer sites, as opposed to something which is done for them. There is also a unified security manager, which tries to. Go ahead.
Yeah, unified secure channel. Yeah.
Oh well, so there's two different things. There's the unified secure channel, but there's also the security information controller shield, right? So there's two different things. There's unified secure channel, which is a set of technologies developed by Huawei that's inside OpenDaylight that allows for you to essentially create encrypted tunnels to a unified secure channel agent in another network, which you can use to do anything you want, from doing control of a device across the WAN to anything else. There's also a controller shield project which tries to provide a unified set of information about all of the different devices and whether the communication with them is currently encrypted or not, so that way you understand what's going on. So this stuff all exists. For better or for worse, security is a holistic thing, and so users really need to understand what their security needs are and how to meet them with the tools that we give them. And pretty much anything I think we would do on our end would likely only complicate getting it actually securely deployed on a user site, sadly. How stable are the cluster tests on Beryllium? I haven't looked at the cluster tests recently, but I work really closely with Luis Gomez and James Lurson, who are the two people who do them. And my understanding is that they have gotten quite stable towards the end of Beryllium, and so we are still flushing out. I mean, I'm sure there are still bugs in our clustering because there are bugs in everybody's clustering, but they are stable. If you set up a cluster correctly, our experience is that it does really work.
Yeah, and again, we can reach out. Yeah, no, I was just going to say, again, the community is very welcoming. Reach out to Luis Gomez. There's also a clustering testing meeting specifically that happens every week on Thursdays. And if you go to the wiki, there's a page that has all of our events. There are all of our meetings that you can go to.
Are you planning some more technical deep dive sessions regarding architecture, et cetera? We certainly could. If you have questions, you can ask. And either here or on the mailing lists, or come talk to us at our booth at the Open Networking Summit. Do we have documentation on how to replicate cluster setup in Beryllium? There is documentation on cluster setup. If you want, my suggestion is if you really, really want the actual automated ways to deploy a cluster of Beryllium, I would suggest go looking at our tests. They're checked into our integration test repository, and those things are the things that have to actually deploy the cluster and have it work. So they're guaranteed to be up to date and they're guaranteed to work. There is also documentation on how to deploy it, and I'd have to dig up that link, but I can. I think it's still available in on the wiki, and I'd have to. And Phil, if you can find that link, it would be really useful.
Yeah, let me work on
Can the MD-Sal layer use an DBMS like MySQL or Oracle as a backend? Does it use H2 by default? So the MD-Sal uses level DB by default, and it's actually backed by Akka. So it's actually using Akka persistence to store its data. So it is in memory and memory alone when it's running, but it is persisted to disk by Akka's persistence layer using the level DB plugin for persistence. Anything which can be loaded as an Akka persistence plugin could thus be used as the persistence layer for the MD-Sal. What do I think about firewall integration in OpenDaylight? Is there any running firewall integrated with ODL in production? I'm not entirely sure I understand the question. I certainly know of places where people have used firewalls to make sure that the OpenDaylight controller is protected from many attackers. I know of situations where OpenDaylight has been used to control firewalls, either through netconf or other protocols. We don't have any. I don't think we have any particular support aimed solely at firewalls.
No, not that I know
of. Is OPNFV built using OpenStack and OpenDaylight? Can OpenDaylight be used to configure and manage VNF nodes deployed in OPNFV? So I believe, but Phil, you can correct me if I'm wrong, that OpenDaylight can't actually manage, or it doesn't by default manage or configure VNF nodes, although it certainly could. It's in OPNFV. In OPNFV, what OpenDaylight is used is to actually chain together already deployed and configured NFVs or VNFs. Do you have a different understanding of that, Phil?
No, that is my understanding as well.
That being said, I know of deployments where it is that OpenDaylight is used to manage the VNFs, to actually control them. As an example, the AT&T bandwidth on demand service, the bandwidth on demand is provided by virtual network functions, and they are controlled using netconf by OpenDaylight. There seems to be some issue with AAA and Deluxe and OpenFlow plugins in the Beryllium cluster setup. Did anyone test and validate this combination? Yes. Please send mail or file a bug, and we'll fix it if there's something that's wrong. It is the case that I think by default the AAA plugin does not use the clustered data store to store credentials. So the credentials could potentially be different in every single node, but I probably don't think that's the question. Please email the AAA list and ask. How does latency impact clustering, e.g. a cluster with 80 milliseconds latency between controller nodes? I don't recommend that. So in order for each, we replicate each transaction to at least one other node. So in a 3-node cluster, which is the smallest that gives you high availability, we replicate every transaction to at least one other node. And so the result is transactions have to pay the latency cost of the latency between controllers. So there are circumstances in which an 80 millisecond transaction latency would be fine. It just depends on the performance that you want to get out of the controller. In general, we have tested OpenDaylight when there is very low latency between the nodes of the cluster. So you could test it. It will certainly work. It just might be slow. Do you have plans to implement release reservation paths or other resources plugins? Yes, there is a resource reservation project inside of OpenDaylight. I think that did they make the Beryllium release or not, Phil?
No, they did not.
Okay, so there are plans to do it. They did not ship it part of Beryllium. If you're interested, I encourage you to reach out to those people. If you search for release reservation OpenDaylight project, or just go to the wiki and search for release reservation, you should probably be able to find them. In terms of pathing, there are path computation engines inside of OpenDaylight, both inside the L2 switch project, as well as inside the PSEP project, which is the path computation element protocol, so there is a way to use it and that's designed to be used with BGP, but you can use it for other things.
Yep, the folks who are doing the reservation project, sorry, Colin, the folks that are doing the reservation project are busy also working on other areas of OpenDaylight. So I'm sure they'd be very happy to have folks join them if the more in the community would like to see reservation come to life.
Has ODL service chaining been tested with hardware appliances as middle boxes for chaining? I think the answer is no, but there's no reason it couldn't work. Read from followers in a cluster setup is still an issue. Is there a way to tie in config and operational shards of the same node to the same cluster node? So okay, so at any given point in time, for every Yang module in OpenDaylight, there is one shard leader, and there are, if you're using 3 nodes, 2 shard followers. By default, all reads go to the leader because that simplifies the distributed systems understanding for people, because that means everybody will get the same answer. We still do that, relaxing that to read from followers in certain circumstances to allow people to read faster, older data is something that we are actively working on. And because it's done at the module level, by definition, the same node will be the leader for both the operational and configuration sides of the data store. How can SDN federation be achieved by means other than SDNI? You would have to write it. So that's not quite true. That's a little bit glib. So you could imagine using OpenDaylight's RestConf interfaces to do federation. So you could actually have one controller talk to the other controller using RestConf in order to be able to understand what's available there, and have looser integration there across the RestConf interface and using a different data store, which would be the way that I would probably go about it. SDN expands the threat service. How is ODL addressing them? So in general, I guess I don't know that I agree that SDN expands the threat surface. It certainly creates another object. It doesn't expand the threat surface of the existing things which are going on, but it does certainly add a controller, which is now very powerful and a potential attack vector. And so in order to address that, we do a couple of things. One of them is our recommended deployment model is that the controller should be deployed in a management network, which is kept more secure than the data network. But beyond that, as we discussed earlier, we support encryption between the controller and all the devices. In most cases, we also support either unidirectional or bidirectional authentication using crypto of that. So it's possible to have your OpenFlow nodes actually authenticate the controller, and the controller authenticate your OpenFlow nodes. And lastly, I think we have sort of one of the most robust security response processes in the open source space. we are very, very attentive to security issues and fix them quickly. On at least one case, we've gone from hearing about a vulnerability to having the shipped version that you could upgrade to out and on the download page in less than 4 days. Are the versions on the Docker Hub current? I don't know, but probably not. Do you know, Phil?
No, I do not know if they're current.
All right. For the NFV use case, is there any purpose besides SF service chaining that we will need ODL that OpenStack by itself cannot support? In general, my experience, and this is asking about NFV, I'm not sure I quite understand the question. So I don't think that OpenStack by itself does very much in the space of NFV and service chaining. I mean, Tacker is doing VNFM, but my intuition is that both OpenStack and OpenDaylight are working very hard and oftentimes together on making network function virtualization work. So my guess is that any huge differences are likely small at this point in time. But in general, the difference between OpenStack networking and OpenDaylight networking has been that OpenStack networking usually assumes things are virtual and assumes that the network is essentially infinite bandwidth and highly reliable. Whereas OpenDaylight takes, because it is network-centric, takes a more nuanced view of the network, including allowing better support for hardware as well as virtual objects, and also allowing for understanding of the underlay topology and perhaps doing optimization of paths in a more meaningful way. Which data store configure operational does XSQL tool show data from? I think the answer is either one, but I would have to go look at it and use it again. It's been a while. Probably by default, it looks at the configuration. Any information about the SAL, any attempt to align it with other things like the ONF, MEF, or OPNFV? So the Yang models in our service abstraction layer are often derived from sources like the IETF and like OpenConfig. We recently participated in a data modeling workshop with all of those organizations, including Etsy in Denver. I don't know, Phil, if you want to add anything else there.
Yeah, no, I mean, you said it right. We by and large use the Yang models, and data models that are available, and we make up our own when we need to. We try not to do that any more than we absolutely have to. We certainly go to the standards organizations first. Okay,
so has two-node clustering been implemented? There is no current two-node clustering implementation. There was an extended discussion about it at the beginning of I think during Lithium or the beginning of Beryllium, in which an architecture was proposed, but the architecture was never implemented. If people are interested and want to help, we would always accept it. And there's been a lot of work around how it would work and how it would integrate with our clustering. So how does upgrade work from Lithium to Beryllium, and how and can a live deployment be upgraded? So updating from Lithium to Beryllium is something which is a little bit complicated and involves understanding what applications you have and what's changed about them. So it involves some pretty careful understanding of what's going on there. The simplest recommendation I would have is to shut down the controller, install the new thing over it, and before you install the new thing over it, I would get all of your data out of the controller using REST calls, and then I would try and put the data back in and see where there are problems. So the short version is there is no automated upgrade that's available. My experience has been that for specific users with a specific set of features enabled, that upgrades are often possible but involve a little bit of care. Is there a plan to enhance the documentation? So there are lots of plans to enhance the documentation. The PDF documents that are available on the downloads page are the most cleaned up and useful documentation that we've sort of put together, and we're hoping to publish them as HTML versions as well. The Getting Started guide has been totally revamped and I think will be pretty useful. But yes, improving documentation is near the top of our list. If OF plugin is used as a stateless components with reduced data store transactions, would it help scaling this outbound? This may be specific to a use case, though. Hi, Muthu. And yes, I think that if performance is your top thing and you can get away without having to record any state, you could probably modify things in order to be able to be faster. That isn't something we do because I think most people want to keep the state around. Is there a place where there would be instructions? The USC project, and you found the USC page. Sweet. Do you have performance tests about controller traffic during leadership change? I don't know. Specifically about performance during leadership change, I don't know. We have a, if the leadership change is graceful, which is to say the leader goes down, it tells somebody else to take over for it. And so that leadership change should have little or no performance impact. If a leadership change is unexpected, there's sort of a fundamental trade-off between efficiency of not stopping to wait and of accidentally thrashing if the leader is just a little bit slow. So, so there's going to be some impact in non-graceful changes, but sort of that's fundamental, and it can be tuned to your particular needs. Has anybody tested synchronization between multi-controller network where the controller is separated by 80 milliseconds and a single application wants to make changes, the end-to-end flow going through switches controlled by the different controllers? I don't know. Not to my knowledge. Again, I think it should work. I think the only it will work. So if there's an 80 milliseconds latency between all three of the controllers, it will probably work slower than normal. Whether or not it works fast enough for you, you would have to test. So is there any latency requirements on the disk? We are sometimes seeing disk latency of 100 milliseconds, and it does cause the shard leader to change in the cluster. Interesting. I hadn't considered the idea that the latency to disk would be 100 milliseconds. My guess is that that our code probably does expect shorter latencies to disk than that. My guess is that we could probably change it so that way it doesn't require less than that. But effectively, we require, we assume that people want to have all of their transactions persisted. And so before a transaction is applied, we actually make sure it was written to disk. So that would be effectively having 100 plus latency between all of the nodes in your cluster. Which, as I said, would probably be beyond the scope of what we tested and think it should work with. If there isn't already a knob to do it, we could probably add a knob that allowed you to basically persist in the background so that you wouldn't eat that 100 milliseconds of latency at the cost of maybe losing some data if you had a failure. Do you have any plans to support the 1+1 model in OpenDaylight clustering? As I said, we have an architecture laid out for how it could be done, but right now we don't have anybody that's vehemently asking for it, or anybody that's currently working on it. So if you want to do one of the two, let us know. And what's the plan for hitless upgrades? Our plan for hitless upgrades is essentially to basically have a 3-node cluster at least, and to upgrade each individual node of the cluster and leave the other 2 running as you go. And then support the ability to have multiple different versions of OpenDaylight running in the same cluster and interoperate. When exactly that will be done isn't obvious to me. I'd like to say boron, but my guess is that's probably going to be a little bit later than boron. But with sufficient resources and sufficient interest, it's an open source project and anything can be done. I think that's all of the questions that we have. Anybody else have more questions? Cool. So please go check out OpenDaylight, and thank you so much for coming. And I guess the thank you slide isn't particularly useful, so I'm going to go back to where it is that you can go to opendaylight.org/start and actually get started using it, because that's what would be most interesting to me. So if you're not including clustering loses HA if only 2 nodes are available, but they're So let me read this carefully. So the 3-node HA clustering loses HA if only 2 nodes are available, but there was a proposal for 2-node that would allow you to keep monitoring and manipulating the network if one of the 2 went down. Yeah. So it is true that so it's true that if we use strongly consistent data store, so that way you make sure we don't lose any data and everybody agrees about what the data is there. And in order to do that, you need to have a majority of the nodes up to continue to work. It's part of the CAP theorem. And so the result is that the 2-node clustering would have a different set of semantics, which is fine. We haven't gotten there. And so if you use 3-node Raft, you get the current consistency model. We don't have a 1+1 environment there. And so it doesn't mean that changing a leadership before failure or enforcing a deterministic way to failover. So we do graceful leadership change. That is actually where basically the node says, I'm going to shut down, so please somebody else run to become the leader. And that starts an election, which then happens. And when it happens that way, the election time takes almost no time, and there's almost no hit. If instead you have to wait for the leader to be determined to be dead, that's a configurable amount of time, but I think it's measured in like single-digit seconds, like 3 seconds or something like that. So it is potential that between when the leader fails, and that's configurable, and when the controller returns back to being functioning, that would take a couple of seconds. For more detailed questions about clustering in OpenDaylight, there's a clustering call that happens on Tuesday mornings Pacific time, and I would strongly encourage you to attend. OpenDaylight, is probably a little bit different from a lot of things that else are here. We are a big, open, and welcome community. So, don't let this be the end of it. If you're at all interested, please come and join us. And whether it's at the ONS or on our IRC channels or at our meetings, please, please, please come.
This is Phil, and thanks everybody for for developers, or if you're looking to get involved in the developer community, yes, come to the Wiki, come to the IRC channels. Again, we on the Wiki we post the meetings that we have. If you're more comfortable joining a meeting as opposed to email or IRC lists. And similarly, if you're a user and you just want to understand what user issues are and what they're looking for, we have an open call from the user advisory group on a monthly basis, and that's also posted on the Wiki. So we invite you to come join. Thanks, everybody.